Hey y'all, this is a lesson on multiplying and dividing rational expressions. I put these in the same lesson because division is technically just multiplication of fractions, so they're really the same thing. Let's review multiplying fractions really quick just to get the mechanics down. Remember, when you multiply fractions, you multiply straight across. So 3 times 1, 4 times 8, and then reduce if necessary. And then when you divide fractions, you have this rule that you might remember. You flip the second fraction and multiply. And the reasoning behind that is if we were to write this as a ratio of fractions, whoops, nice little trip there. Then if we were to simplify that, we could flip this and we end up getting 8 over 8 in the denominator, and we have this, which is what you see here. So that's where that comes from, and that's why we have the rule flip the second and multiply when you divide by fractions. So when we multiply fractions, you multiply straight across. And when you divide fractions, you flip the second fraction and multiply. So really, we're just multiplying. A rational expression is the quotient of two polynomials, the second of which does not equal 0. And so if we're going to multiply or divide rational expressions, it follows the same rules as multiplying or dividing fractions, because a rational expression is just a fraction. So here's a couple examples here. We're going to start simple. In this top box right here, I don't have any multiplying or dividing, but I just want to show you that it's very easy to do. In this example, we have this quadratic in the denominator. I'm going to factor it quickly with the shortcut. I do have a video on factoring trinomials if you want to go back and watch that, but I am going to jump straight to factoring. So I'm looking for factors of 21, negative 21, that add to 4. I'm going to use a positive 7 and a negative 3, because 7 minus 3 is 4, and 7 times negative 3 is negative 21, so it satisfies both. And then I'm going to rewrite this rational expression in factored form. The top is already factored because it's m to the first. And you'll notice that I have this m plus 7 in the top and in the bottom. Since we only have multiplication here, I can very easily divide those common factors. And we're left with a 1 up top. We don't put a 0. When something divides, it divides to 1. So for example, 3 divided by 3 is not 0, it's 1. So over here, when we have m plus 7 divided by m plus 7, it's 1. And what we're left with is 1 over m minus 3. You could go on to say m cannot equal 3. That's a different lesson, but if you were curious, if you needed to state that, m can't be 3 because 3 would make the denominator 0. Again, that's a different lesson, but just throw that in there for this example. We have another rational expression Both can be factored. In the numerator, they share a 35. They're both divisible by 35, greatest common factor. I do have a video on greatest common factors also. And in the denominator, they're both divisible by 5. So 5 is the greatest common factor. These are not the same, so they do not divide. These are also not the same, but they do reduce. What is 35 divided by 5? 7. So we're left with 7 times x minus 1 over 5x minus 8. And that would be completely simplified. You can leave this in parentheses if you want to. It really doesn't matter. So let's use that and our definition from the beginning for multiplication and division and try these. I have the multiplication of two rational expressions. So the first thing you can do to help you simplify this is go ahead and factor anything that can be factored. We are going to pull out a 7 from here, and then we're looking for factors of 40, negative 40, that add to negative 3. So that's going to be, let's see, 1 and 40, 2 and 20, 4 and 10, 5 and 8. Ooh, 5 and 8. 1 negative. So that they add to negative 3 and they multiply to negative 40. I'm going to rewrite this so that it's a little more organized. I'm going to put this in parentheses just because I like that. And we know with multiplication, we can multiply straight across. So I'm not going to actually multiply these out, but I am going to write them together on the same line. If I multiply it out, I'll end up with I'll be where I started, and I'm really trying to simplify, so I don't want to do that yet. You might notice that we have x plus 5s and x minus 8s, and we're left with x plus 7 over 7. Now, right here, I don't want you to be confused. There is a 7 in the top and a 7 in the bottom, but that cannot be reduced. Why not? Because this 7 is part of x plus 7. So this whole thing is a factor. And 7 is a factor. So that's kind of why I like having those parentheses there, because it shows that this whole thing is a factor. If I had, for example, a 7 outside, then those 7s could reduce. But I didn't have that. I have this factor, and they're not the same, so they do not reduce or simplify. I shouldn't say reduce. Okay, next one. This one looks like fun. Let's see. Go ahead and factor. Anything that you see can be factored. I am going to also multiply, which means I'm going to put it all on the same line. So what I'm factoring is this. I'm looking for factors of negative 36 that add to negative 5. Let's see, 1 and 36, 2 and 18, 3 and 12, 4 and 9. I made it a negative 9 and a positive 4 so that it makes negative 5 when you add them. And on the bottom, I have x minus 9. And with this, I have a greatest common factor of 3x squared, and I'm left with x plus 4. So I am factoring quickly. If you're having trouble with factoring, if you're not seeing where I'm getting these things, please go back and watch my factoring videos. And now that I've multiplied everything in the numerator and everything in the denominator, everything is multiplied. Now I can start dividing common factors in the numerator and the denominator. Let's see. Is there a 45x squared? Let me do this really quick. There we go. There's not another 45x squared. I do want to kind of stick a pin in this. I am going to do something with this, but I'm going to do it in the next step for no reason other than I want to. X plus 4 and x plus 4, there's one on the top and one on the bottom. X minus 9, one on the top and one on the bottom. And what we're left with is 45x squared over 3x squared. So this is kind of the reason, I didn't really have a specific reason as to why I left it, but I did leave it because I knew that they could reduce, but it was a little hard for me to see with it kind of wonky like that. So when I put it this way, when it's organized this way, it's a little easier for me to see. Organization is very important in mathematics to keep things lined up, in order, very clearly shown, with your work. It's all very important. It all helps you get to the final answer more effectively. So 45 divided by 3 is 15, and then we have an x squared and an x squared. And so we are just left with 15, which is so crazy. I think it's so interesting in mathematics how you can start with that and end with that. Very cool. Math is cool. Okay. And then division. Now remember with division is actually multiplication, but we have to do something before we can multiply. Now the reason why I'm doing this in the first step is because I always forget if I don't do it in the first step. So I'm going to leave that for now. I will fix it. Change that, flip the second fraction, and now we're talking business. So I would encourage you to go ahead and do that before you factor, because usually if you go ahead and start factoring, you'll forget that you need to flip this. You'll go ahead and multiply and your answer will be wrong. So I would encourage you to do that first. Now you can start factoring. I'm going to leave this. I'm going to go ahead and multiply my numerator. Let's see, factors of -8 that add to 7 will be a +8 and a -1. And then I'm going to factor this. They share a 7 and an a squared. And I'm left with a plus 8. And then don't forget this little 2 right here. Now everything is on the same line. Everything is factored. Everything is being multiplied. Now we can start simplifying, which means these a plus 8s and these 7s and these a squareds. So we are left with a minus 1 over 2. Super simple. Last one. We have a division here, which means that we need to flip and multiply. Now I need to factor factors of negative 15 that make negative 2, b minus 5, b plus 3. This has a GCF. I'm going to pull out a 2, and I'm left with 2b plus 5 over, so I went ahead and multiplied those in one line. This has a GCF of 4. And then we have this little trailing 2 that needs to also be in there. So I went ahead, I kind of did 2 steps at once. I did factor this, and I did multiply them together. I didn't actually multiply them together. I want to keep them in factored form so that I can simplify. I see these 2's. 2b plus 5 is my favorite step. I love to mark stuff out. And it looks like I'm left with this stuff. So that is the answer. Don't bother multiplying it out. You shouldn't need to. You should be able to just leave it. And that is all for this lesson. Super simple. Like I said, if you have trouble with factoring, please go back and watch those videos. And if you have any questions, please